Hi, this is Stephen Rare from Raton Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And this is for signed comparisons. And we'll look at JL and JG. JL for signed less than comparison, JG for signed greater than comparison. And this is the program here is a silly program. It doesn't really, it's really meant to illustrate a point. And oh, by the way, let me just pop over here. Of the 5 demo files in Canvas, this is the JLJG signed demo, which I copy and pasted into Visual Studio here. I already did compile. Let me just run it. The silly thing is, it generates a random number, and then it asks you how you want to adjust it. And let's just pretend we like things that are 5, a multiple of 5. So 2 less will put me at minus 10. So if I did an adjustment of minus 2, so we had minus 8, we added a minus 2, we ended up at minus 10. It's a silly little thing. Let me just go and do this again. So 1, it is allowing me to enter a negative. Well, suppose I want to also go to minus 10 here. Let me do a minus 9. The value is too small. So what I have is a range. I'll just see if I can do it here. The min adjustment value, the lowest can be minus 5. So minus 9 is too small. So if I wanted to get to minus 10, for this silly little program against a silly program, I can't do it, but because it's the minus 9 is less than the minus 5. So that's the signed comparison, which we'll have to then do the JL for. So actually, let's see if I can find that. If I look in here, this is where we'll give the prompt, enter adjustment amount, read int, that's the signed read, and the result of read int, EAX has the value, and here it'll compare EAX to the min adjustment value, which was minus 5, and so JL, which is the signed less than, JL is the too small error. So then in this case, if I look at too small error, it displays, well, that's too small, and then it jumps back to the get of the adjustment value. So the JL being for too small, and so now let's say I want it to go to, well, for minus 1, if I do 6, it should be 5, right? So if I do 6, that's too big, because my max adjustment value is 5. That's the maximum one that it can be. And then here, here, JG, that's the test to see if it's greater, then it's going to go to the too big amount, and the too big amount, it displays the error, and then it jumps up to here. So I have to put something in the minus 5 to 5 range. And so let's just, for giggles and grins, let me put in 5. And then that 5 worked, which brought me up to 4. Again, this is the aspect of the program that is silly. But what's happening here is the 5 wasn't less, the 5 wasn't greater. And so that's when we went and adjusted the value and then jumped to the display results section. Okay. If we end up using the wrong conditional jump, we'll get some results that aren't going to make sense. In other words, say, well, suppose you just do JB, below, less, what's the difference? And so let's say you do JB for the too small error. So minus 8. So it does say it's too small. Okay, 55. Huh. It's saying it's too small. The 55 is too small? How can 55 be too small? 55 should be too large. So by using the JB, this is firing in the wrong direction. Matter of fact, I can't seem to get out of it. Oh, there you go. Finally, a -1. It finally said it was fine. So anyway, let me put this back to the JL. And suppose here I ended up doing JA for jump above. And so first for the jump above, if I do 6, it's too big. That's fine. And I do 5, it should work. That's great. But if I do -1, it says it's too big. Because -1, the leftmost bit is a 1, and the JA is really doing an unsigned comparison, and that's why I would look at those as not being the same. So the point is, and I'm not doing a good job for this, is that if we're dealing with signed numbers, we have to make sure we use the signed conditional jumps. So the JG and the JL in order to handle the if something is too small. So -6 is too small, -5 is valid. And then again, the 6 is too big, but the 5 is valid. Okay, so again, up in Canvas, the JL, JG signed demo file has this for the signed comparisons. This part of the video ends the signed part. I was just going to talk about random numbers. If you don't want to hear the random numbers now, you can stop the video. But in terms of the random numbers, I just want to point out is that I have these two constants here, these symbols. The min random number is -10, the max random number as 20. If we think of the difference between the two of these, well, it's the higher minus the lower plus 1. So 20 minus -10, that'll be 30, plus 1 is 31. So there'll be 31 possibilities from -10 going through 0, getting up to 20. So on the generating of the random number, now again, this is done at compile time. So the max random number, which is 20, minus the min random number, which is the -10 plus 1. So, compile time, this part here is calculated as the 31. So 31 is going in as the random range. And so random range would actually give us from 0 to 30. We add in the minimum random number, which is -10. And so what it gives us in terms of the range is from the minimum random number to the max random number, just by adding in that min. So I just wanted to point out on the random numbers how I was coming up with those values. That's why sometimes it was coming up negative. It's mainly it's generating a positive value. Because in other words, we're passing in 31 as being the random range, which will give us from 0 to 30. We're adding in the min random number, which will then give us the -10 to the -10 to the plus 20 in terms of the range. Sorry about that little train wreck at the end, but I just wanted to point out the random number piece. Now this is the end of the video. But wait, there's more.